in chapter 12 is about calculating the derivative. We looked at the meaning, the concept of derivative in chapter 11. Chapter 12, we're actually going to have rules to find the derivative. We'll have formulas. We'll have formulas to find formulas because derivatives are actually formulas. So the first section is about techniques for finding derivatives. This first page is about notation. The notation you will most often see me use is this first one, f prime of x. The derivative of f of x is f prime of x. You will hardly ever see me use that last notation, but that is the notation that's used in a more formal calculus course. Those of you that have a TI-84, that middle notation is actually really similar to doing the numerical derivative. When you call up that routine on your calculator, it actually looks like that one in the middle because it'll be d over d, and you'll have to fill in the x, and then in the parentheses you'll have to fill in the function f of x, and then after it there will be a little sub x or something, and you'll have to either put in a number or you'll have to put in x if you want it to calculate a formula. Yeah, here's the problem, guys. Right there.
Oh, that's a big part.
You have to take all the plots off.
Oh.
Those have to be blank. If they got black boxes on them, you'll get an error message.
Okay, all right, thank you. I thought it needed to be reset or something.
No, that's okay. It may need to be reset, but not just for that. Okay, the other notation for derivative is this one, and it basically is just leaving off the definition of the function afterward. dy over dx is the same thing as f prime of x. Just like you learned back when that y equals something something x squared plus something x and yada yada, that was an equation, and if it was function notation, it was f of x equals all that stuff. So f of x and y meant the same thing. Well, now here we're saying that dy over dx and f prime of x mean the same thing. What the dy is it's saying the difference in the y values over the difference in the x values. The d stands for difference. So basically dy over dx is just emphasizing to you that the derivative is a formula for slope. That's really what it is. It's a formula for slope. These rules will hold true. There will be just rules to you until such time as we do some examples. But what this rule says is that if you have a function that is a constant, such as f of x equals 3, then f prime of x is equal to 0. The derivative of any function that has no variable in it, it's just a constant, its derivative is going to be 0. The reason for that is because if f of x is a constant, well, that's the same as y equals whatever that constant is. That's just a horizontal line. What's the slope of a horizontal line? All together, 0. So the derivative of a constant is 0 because it's the slope of a horizontal line. This is actually called the power rule. What the power rule says is that if you have a function such as x to the first power, then what you're going to do is you're going to bring that power of 1 that's understood to be there, you're going to bring it down in front of that x, and then you're going to reduce that power by 1 to make it x to the 0. So x to the first derivative is 1 times x to the 1 minus 1, or 1 times x to the 0. What is x to the 0? That's 1. Anything to the 0 power is always 1. So 1 times 1 is still 1. If you have x squared, you bring your 2, which is your power, down in front of the x, and then your power becomes 2 minus 1, So that's 2 times x times 2 minus 1 is 1, or 2x to the first, which is just 2x. If your power is 3, then again, the 3 comes down in front of the function. F prime will be 3 times x to the 3 minus 1, so it's going to be 3x squared. So all you're doing in every one of these, even if the powers are negative, is you're dropping the power down in front of the x, and then you're reducing the power by 1, and that's the derivative. So here we have x to the negative 1, so the negative 1 comes down in front, times x raised to the negative 1 minus 1 power is x to the negative 2 power. Now I'm fine with it if you leave it like this. I'm not really going to push you about simplifying a lot of these, but you do need to recognize later on, because it'll help you with manipulating things into a form you can use more easily, that x to the negative 2 power is 1 over x squared. Negative power simply means you drop your variable down in the denominator and change your power to positive. And then x to the 1/2, it still works the same way. Bring the 1/2 down in front, and 1/2 minus 1 is negative 1/2. And so this, while it's fine with me, that's also equivalent to 1 over 2x to the 1/2 power. Okay? So the next one we see is just, this is the generalized form of the power rule. It basically is explaining to you how you deal with a variable raised to a power. You have a variable raised to power, and the power has to be a real number. It can't be imaginary. But as long as the power is a real number, then you bring that number down in front and use it as a multiplier. Use it as a coefficient. And then you reduce. You subtract the power by 1. And that'll give you the derivative. So now we have some examples. I want you to find the derivative of f of x equals x to the 6th. What do you think that is? It's okay to be wrong. You can't learn if you don't make mistakes. 6x to the 5th. Okay? That's exactly what it is. So let me switch over here. We'll look at some more of these together. I can move it up maybe. Control it a little better. Okay, so if we have f of x equals x to the 6th, then f prime of x is equal to, bring the 6 down in front, times x to the 6 minus 1, which is 6x to the 5th. Okay? If we have y equals t, the variable is t. The function is y. Even though it's not in function notation, we can find the derivative. Y prime. And y prime, what's the power on the t? 1. So we bring the 1 down in front, t to the 1 minus 1. And t to the 1 minus 1 is t to the 0. And 1 times t to the 0 is the same as 1 times 1, which is just 1. And then we have y equals x to the 1 over x to the 3rd. 1 over x to the 3rd. I got a problem. My rule didn't say anything about 1 over x to the 3rd. I can only do that if it's just a power, and this is not just a power, there's a 1 on top of it. What am I going to do? Well, I have to recognize that 1 over x to the 3rd is exactly the same as x to the negative 3. So if y equals x to the negative 3, what do I do with the negative 3? Drop it down in front, and then subtract 1 from the negative 3. And negative 3 minus 1 is negative 4. Okay? Now you try one. Y equals x to the 4/3 power. Follows the same rule. Power comes down in front, subtract 1 from power. Tell me what you get. What's the coefficient going to be? What do you think the coefficient is? Four-thirds. Okay, so y prime equals 4/3 times x. What's the power going to be? What do you think, Tom? What's the power going to be? What do you do with the power after you've dropped it down in front and used it for a coefficient? What do you have to do with the power then? Subtract 1. So what's 4/3 minus 1? 4/3 minus 1. 1's the same as 3/3. Got a bracket calculator that does fractions. Okay, good job. So it's 4/3 x to the 1/3. Because 4/3 minus 1, 4/3 minus 1 is the same as 4/3 minus 3/3, and that's 1/3. And no, nobody's safe. I will call on you by name. I've had most of you in class before, so I know your names. Okay? Okay, the last one we've got is f of x equals the square root of x. Who remembers what power corresponds to a square root? It's a 1/2. Excellent. So f of x equals the square root of x is the same as x to the 1/2 power. So now that we know that it's x to the 1/2 power, then how do we find its derivative, f prime of x? What does the power rule say that you do? Okay, so what's the power rule say? It's right there on your handout. What do you do with the power? Where do you put it?
After watching this one, I ain't had it down.
You'll make sure you pay attention this semester.
Oh yeah, I'm really.
Okay, here's your power rule. What does the power rule say that I do with that 1/2? what's the power if it's the power of 1/2? What's the power? No. This says that you bring the power down in front and you decrease the power by 1. So what power do we have? Help him out. Okay, the power's 1/2, it drops down in front. Now that I have dropped it down in front, what do I need to do to the 1/2? Subtract 1. What's 1/2 minus 1? Positive or negative? Negative. Good job. Now, your textbook would probably tell you that you need to make that into 1/2x to the 1/2 power. I will take it just like it is. The last time I checked, my math lab will also take it like that. If it ever doesn't, click the Ask My Instructor button so that it'll come show me what you did, and then I'll go in and look and see if what you did was equivalent to what it wanted. But I have noted, since I have taught through this out of this book before, I did find out that my math lab would take equivalent versions, whether they were nice or not, or simplified the way a mathematician would want it, or if they were just in the form that I could tell what rule you used. Honestly, if you show me this, I would prefer that. And the reason I would prefer that is because that shows me you knew how to do the rule. If you try to convert it with, rusty algebra skills and get the wrong answer, and you don't show me the trail of your steps, you may have known perfectly well how to do the derivative and you just got messed up in the algebra after that. So I want to see that first step. Okay, I want to see the first step. I don't care what you do to it after that. I want to see that first step. Show me what the rule said to do. Okay? Okay, our next rule is called the constant rule. It says if K is, and K just stands for constant, if that's a real number, and you have a function where it's a number times another function, g of x would be like x squared, or just x, or square root of x. It could be anything, but there's a number in front of it. It has a coefficient in front of it. What you do with that coefficient is you pull it back out in front of the derivative, and then just take the derivative of what's left. So I'm going to demonstrate a couple to you, and then I'll ask you to do some. And I'm going to go from the bottom. I'm going to do the harder ones first. Leave you all the easier ones. So I'm going to start at the bottom. Here's f of x. And f of x is the constant 4 times the function, which is the cube root of x. So when I take the derivative, the first thing that I'm going to do is I'm going to pull the 4 out in front of the derivative, of this function here. So the 4 is going to be times the derivative of, what power is this? If square root's 1/2, what's cube root? 1/3. Okay? So this is the constant, this is the function. I brought the constant in front, and I'm going to take the derivative of the function, and here's what the function was. So what is the derivative of x to the 1/3? I'll give you a quick way to remember the power rule. The power rule says drop and decrease, drop and decrease. Okay? Drop it in the front, decrease by 1. Drop it in the front, decrease by 1. So we're going to drop it and decrease it. So the derivative here is going to be 1/3 1/3 x to the 1/3 minus 1, and there's a 4 still sitting out in front for that 4 that was in front of the cube root. So what's 1/3 minus 1? And at this point, if you can't do fractions, I don't care. Just get to your calculator and remember that parentheses 1 divided by 3, because fractions always go in parentheses, subtract 1, answered as a fraction, is -2/3. So not being able to do fractions is no excuse. You got a calculator, doesn't fine. So this is going to be x to the -2/3, and the 1/3 times the 4 is going to be 4/3. So f prime of x, or y prime, is 4/3 x to the -2/3 power. Questions? Yeah, you do have to put the 4 back in at the end. Although if you've left it sitting out in front and then at the end you multiply wrong, I'm not going to count the problem wrong. I'm going to go back and look and see that you had pulled it out in front. And then maybe you said, you know, you had a brain leak and you said 4 times 1/3 is 3/4 or something. I'll circle it. Not make a little frowny face. Then I'm going to count it wrong. Okay? Now that's the hardest one on there. I'm going to do the 4th example for you also. The 4th example is f of x equals 3 times x to the 4/3 power. So f prime of x is going to say, leave that 3 alone. And then I want to take the derivative of 4/3. Leave the coefficient alone, leave it sit there by itself. That's just decoration on the variable. So what is the derivative of x to the 4/3? Drop the power. And then reduce the power by 1. Josh, what do you think? What's the derivative of x to the 4/3?
X to the 4/3. 4/3 x and 1/3.
Yeah, exactly right. Good job. Because you drop the power down in front, and then 4/3 minus 1 is 1/3. So the only thing you have to do to make me happy is realize that the 3's cancel. So that just leaves you with the 4x to the 1/3 power. Okay? Anybody have questions so far? Pay attention now, Travis, because you'll get a do-over. F of x equals 6x squared. What do I do with the 6?
Oh, you talking to me?
Yeah, you're getting the do-over. I do with the 6? Do I need to do anything with it?
Don't you have to, don't you have to minus the 6x squared minus 1, it would be 6x to the first?
Okay, that's
It'd
good.
just be 6x with it.
Yeah, it would just be 6x, that's right. Almost. Okay? Remember, I'm gonna reduce the power by 1, yes, that's true. And I still got that 6 sitting out there, but what did I need to do with that 2 before I minused it by 1? Remember, you drop and decrease. Where do you drop it? You drop the power down in front, and then leave it as a power and reduce it by 1. You got the second part. What happens when I drop it down in front? Do I have just x to the first power, or do I not have 2x to the first power?
Would it just be x?
It is x. But what happened to the 2? This is the basis that you got to get for the 2. What are you going to do with the 2 before you subtract 1 from it? What do you need to do with it first?
I'll let you do that. I'm learning.
Okay, you're learning. That's all right. That's all right. So what you do, the power rule says that you take this 2 and you drop it down in front. So when I bring that 2 down in front, it's going to sit right here. Okay? So you bring your power down in front, and then you subtract 1 from your power. So now I have 6 times 2 is 12x, and I don't need to put the first because I know that that's a 1. Okay? Okay. Y equals -5 times t. What's the derivative of t? Look back on your first page. T is the variable. What's the derivative of t? 1. Okay, the derivative of t is just 1. What happened to -5? Goes along for the ride. So y prime is going to be -5. Because the derivative of t is just a 1 and the -5 just rides along. Okay? Your coefficients just ride along. Got one left. Y equals 4x to the 4 over x squared. Help me rewrite that so that I have something I can use the power rule on. Yeah, 4 times x to the -2. So now help me figure out what to do with the -2. Drop it, subtract by 1.
Is
Okay.
that 4x raised to 2, or is that 4 raised next
No, the 4 is already in the numerator. We're going to bring the x squared up to the numerator and then change the power to negative.
line?
Okay? So I left the 4 there and I brought x squared up and made the power negative. You may need to go, that's going to be in that basic skills review, quiz. It'll make you remember what negative powers and things like that do. Okay, so the 4 is going to come along with for the ride. The -2 is going to drop down in front. And then reduce -2 by 1, I get -3. So Travis says it's -8x to the -3 power. Trying to get it to where everybody can see it. There, I'll just hold it. Okay? Before we go any further, grab a sheet of paper. You're gonna find the derivative on all of these. You got 5 of them to do. It should take you no more than 2 minutes on any of them, so you got 10 minutes. I need to know if you got it. There's no point going on as long as you've got this part. Drop and decrease. That's why they're both on there. Remember what, okay, let's see, that's like this one, or like that one. The one you're looking at follows that one. One of the ones on the quiz here does not follow the power rule. I can show you a way that it does, but it really doesn't follow the power rule. It follows the constant rule, the first one we talked about. Still got a few minutes. Sheet of paper, write the problems down again, pass the one you got with your name on it to the end of the row. This is not for a grade, this is for me to know where everybody is. So don't feel like you didn't, oh my God, I bombed the quiz. No, you didn't. Every quiz I give is for a grade. The quiz today is to take the roll. That's its only purpose. It also lets me see how to do. let's see how you did. Find the derivative. Drop the power, decrease the power. Drop the power, decrease the power. X, the fourth root of x is same as x to the 1/4 power. Drop the power, decrease the power by 1. Okay? This one can be done with the power rule, but it usually confuses people to do it with the power rule. This one is the constant rule. Doesn't matter what the constant is, the derivative is always 0. Okay? Now, I can explain it to you from the power rule standpoint. Because it does, all of the rules for the derivatives actually do follow through for every single one. They all work together, none of them contradict each other. This can be a power rule problem. But you have to first realize that this is y equals 6x to the 0 power, because there are no x's. Okay? And then the power rule says that y prime is 6 times drop the power and reduce the power by 1. And this is why the power rule is not used. Because this is going to be 6 times 0 is 0 times x to the -1. And it doesn't matter that x is to the -1. 0 trumps it. 0 gets rid of everything. So y prime is still 0. Okay? So it will follow the power rule, but it's easier to remember the derivative of any constant, anytime there's no variable, but anytime you have just a constant, its derivative is 0. It goes away. It's nothing. And then for the last one, 6 to the x, and I actually deliberately put all 3 of these in here so that you think about the way that you use the 6. F prime of x, keep the 6, drop the power, reduce the power by 1. But when you reduce the power by 1, that becomes x to the 0, and that's just 1, and 1 times 1 is just 1. So f prime of x is equal to just the 6. Okay? It's just the coefficient.
I just skipped that over.
I just realized it wasn't up there. Okay? Now, if you didn't get them all right, don't worry about it. I can look through everybody's paper and say, okay, they all got this one, they all got this one, they all got this one. They still don't get this one. So that means I'm going to come back and I'm going to do some more work with you, some more practice, and I'm going to make you do it again. Because practice makes perfect. Okay? Now, we're going to go one more. You're not quite done yet. Don't everybody pack up. This next one is not a big stretch. Now this is where we're going to stop, right here. So you go ahead and mark that in your notes. That is where we're going to stop. the extension of the rules that we just had, the constant rule and the power rule, is that if you've got a function that is a polynomial function, in other words, it's got several terms separated by pluses and minuses. What you do is you take each term individually and take each derivative by itself and then just put them back together with the pluses and minuses. So for this one, my derivative is going to be f prime of x, and my first term is 6x to the third. Now this is a trick that I do about the constant and the drop and reduce. I'm just going to let the 6 sit there. So it's going to be 6x, my third power is going to drop and reduce. Drop and decrease. Plus 15x squared. My 2 is going to drop and decrease. So f prime of x is going to be 3 times 6 is 18x to the second, plus 2 times 15 is 30x to the first, or just x. Okay? My second one is P of t. The only thing I have to remember here is that I can rewrite P of t (12t to the fourth) is just fine. I have no issues with that. This needs to be 6t to the 1/2 power, and the last term needs to be 5t to the -1 power. And now I can take the derivative. (12t to the fourth), drop the 4 and decrease it, minus 6t to the 1/2, drop the 1/2 and decrease it, plus 5t to the -1, drop the -1 and decrease it. So what I'll have ultimately is P prime of t is 4 times 12 is 48, t to the 4 minus 1 is t to the third, minus 1/2 times 6 is 3, and 1/2 minus 1 is t to the -1/2 power. Plus -1 times 5 is going to be -5, and 1 minus 1 is going to be t to the -2 power. Now you can write that with the sign straightened out. You can leave out some of the parentheses, but that's basically all you do. You just differentiate each term. That's really all you're doing, is you're doing the derivative of each term by itself, one at a time. And then you come to my third example, and you're saying, yeah, I don't think that's going to be quite that easy. So I'm going to rewrite my third example so we have more room. Okay, the first thing I'm gonna do is I'm gonna change this out for x to the 1/2 power. Okay? Then I'm gonna take this x and I'm gonna split it up between the two terms of the numerator. You can't just cross out that x squared. If you never knew your algebra before, when you do calculus, you're gonna learn it again. Because this is why you learned algebra. This is why also I don't understand why they make people do algebra if they're never going to calculus, because the only thing algebra is good for is calculus, really. So if you've forgotten your algebra, you're going to be remembering it. We're going to break that up and put that x under each piece of that thing by itself. Now, what happens to x cubed over x? What does it become? X squared. Now, before I come to this, I'm going to ask you, how do you know it was x squared?
Right.
What did you do with the exponents? You subtracted the exponents, right? Yeah, 3 minus 1 is 2. The reason I stopped to ask you that and the reason this example is there is because that 3 isn't going anywhere. It has nothing to do with anything. It's just sitting out there in the front. Remember, it's just window dressing. But I've got x to the 1/2 over x. 1/2 minus 1 is negative 1/2. Now, can you take the derivative of g of x? It should be a lot easier now, okay? So this was all algebra, that wasn't calculus. That's why your skills checks are there, because you need to remember those algebra skills to be able to do what you're going to do with your calculus. Calculus is not hard. Everybody that always told you how awful and how hard it is, not in this class. The calculus part's going to be the easy part. You're going to be going back and hitting those algebra books again to try to remember how you simplify things to make you able to do the calculus. So my g prime of x here, drop the 2 and decrease it. Plus 3x to the negative 1/2, drop the negative 1/2, and then decrease it. There's the calculus. Now, wasn't that a whole lot easier than all that other stuff? So now g prime of x is going to be, let's see, 2x, 2 minus 1 is 1. I can write it down or I can leave it off. Because I've got a negative sign here, this is going to trump the plus sign, so that's going to be minus 1/2 times 3 is 3/2. Times x, negative 1/2 minus 1 is negative 3/2. There's your derivative. Okay? We are exactly done right now. I will come back and show you how to do this problem next time. But I'm going to ask you to think about this one. What could you do to make it be just the sum of a bunch of terms? Could you multiply it out? The textbook homework is actually a homework. So yeah, you do need to do it. They're usually not very long assignments. They're probably shorter than the ones in my math lab. But if you're going to look in the textbook, in the e-textbook where those problems are, every one of them has that little pyramid in front of it. So if you get stuck on it, you can click that little pyramid and it'll link to that problem. And then it'll actually step you through either that problem or an example. So when you do that homework, you're really learning better how to do it. It's good preparation before you go into my math lab and do that. Okay? 1 and 10 out of this. That's why I started putting in the skills tools at the beginning first, because when we spent a month in chapter 1 and 10, we didn't have time left to 11 through 15.
I just see them that they're around, I didn't remember.
I may have overlooked it, I'll try to go and look, but I meant to take all that out. It may still even be in my stat lab, but I either omitted it or non-assigned it. Yeah, no, you don't miss anything, you're okay. Oh, the one, yeah, that's what that was. That was really the only thing it wasn't really great.
Yeah, we did the test over that. Yeah, we're right now over,
No, but I'm just telling you that you need to know what those mean, because there will be questions.
Okay, thank you.